All right, and then if you haven't already done so, comment on Travis's idea and whether you think you like it or not. And then think about what Miriam suggests. See how her idea differs. She has a different idea than Travis. Yeah, if you want another color. I like that. So in a minute, I'll ask everybody what we want to say about Travis.
No bother.
I haven't asked if you connected yet because we don't understand what it means to have the in-between values yet. We definitely know what the integer values are, but it's up in the air. It's still we know what the integer values are, right? But we don't necessarily have it settled what's not in between. So I don't know how to great. Yeah. Okay. So is that just what we do? What we do is what Travis said. It's 6, 1.5, or is that 0.9? That's the order. Yeah. We don't know what it is. That's right. All right. I want to hear about Travis's idea. Can I hear from a couple people? Just say it your way. I want to hear a couple voices. I think we can all agree that Travis is not quite right. Right? Or at least there with everybody. He's making a little bit of an assumption I think is, can you explain why? Go. Someone say why you think Travis maybe is making a little bit of a mistake here. Anybody? I'll take him home here. David? Say it again, because what? Yeah, I mean by growing at the same rate, I do understand what Miriam wants when you get down to read about Miriam. Like she kind of might have this criticism of of Travis, sorry. What do you multiply to get from 4 to 6? What's the factor here?
1.5.
1.5. But then if you multiply by 1.5 again, 6 times 1.5 is 9, not 8. So that would be Miriam's criticism, is that like it seems like that whole like multiply by something to get to the next entry in the table seems not to be working for you, David. Sorry, Travis, right? Sorry, I'm mixing up the names. So yeah, it seems like there's not a constant like multiplier or something. You want to say it another way? Someone else? I like that. Daniel? Yeah, if we look at the graph, what is he assuming the shape of the graph is between the red points? It's just a straight line, isn't it? Is what he's kind of thinking. Do you agree that the green point is just the midpoint between the two? All right, so he's assuming it's like, and again, Miriam's criticism might be, I think that it's going to look exponential like on the big, and I think also like in small areas it's going to also look exponential, right? So I think she's got some good intuition there, and I think I like Miriam's idea better. Anyone else want to say what they thought of Travis's idea? So good try, Travis, but let's try figuring out what Miriam is suggesting and filling the table her way. Certainly at 0, 1, 2, 3, and 4, they'll still agree. But what are we trying to figure out at 1/2 and 3/2? I'd like you to think about that with your table if you haven't already.
So
Well, she wants, like what we just said, she wants a constant multiple. She wants that to be something you multiply by 4 to get this value, which we don't know yet. And then you multiply by that same unknown thing to get this value, which we already know is 8. Right? You with me? So whatever this is, this needs to serve that purpose, that there be a number that you can multiply to get from one cell to the next cell in this table. Right? All right, there are the known ones. We still have to fill in the unknown, though, right? So that's my big question right now. What do you multiply by each time as you go from left to right in this table? If it's what Miriam suggested. Do you understand her goal? So there should be something, some number that we don't know yet. What do you figure out what it is? Maybe, but I still, that might be another method to get those out. I want to make sure there's something. Can you guarantee that that will do what we're claiming here? We want to have something multiplied. I don't want to multiply that.
I know you guys are going to bring it back.
Figure out what
Well, you guys have like something. I'll try math again.
You know, our criticism of correct. Different number will multiply. So that fixes it.
Alright, after we go, I'll go to. I got,
Guys, just to clarify the problem in your mind, I think a lot of people aren't clear again maybe what Miriam is asking. She wants there to be a number. What do you want to call it? Because we don't know what it's called in math, we often give it a letter, right? We're not M for multiplier. I kind of like that, or something. Or Miriam. Okay, yeah, or Miriam. All right, so the thing we're multiplying by each time, we have no idea, but we're multiplying by M each time, let's say. So whatever M is, we multiply by 4 and we get this number, which we don't know yet. But if we multiply by M again, that is, if we take 4 and multiply by M and then multiply by M again, what should we get? We should get 8, right? Is that enough to help you understand what M should be? Figure it out. Don't. Figure it out, right? Is that a good way to frame the problem? Shouldn't it be true that we take 4 and we multiply by this unknown number M twice and get 8? Figure out what M is. Figure out what that unknown M is that we're multiplying by. Always. Yes. What is it we're multiplying by? Do you see what I'm saying? It shouldn't be true that we get 4 and multiply by M times M again. So I just want to know what M is.
So it must be so.
That makes sense. That makes perfect sense.
Why not? I got a train that day.
You got it? Figure out what it is.
What would that? That's just different. No, it's like.
You realize that this is what we're looking for, right? We're looking for the M.
So wait, H by 4.
No, the number in the middle box is not going to be a nice number, right? It'll be 4 times 2. 5 points. Yeah.
Oh, so that's all right?
Yeah, that's right. Yeah, it's not going to be a nice number in these boxes, right? All right, help me solve this equation. What's M? How do we figure it out? What's another way to rewrite this?
4 times M squared is
4m squared equals 8, yeah. So what do I do next, algebra people?
divided by 4.
Maybe divide by 4. Someone other than Samantha, finish this off for me. Then what? Yeah, and then you take the square root, right? And you get square root of 2. Yeah? So I think does it make sense now? Go back to the problem we're thinking about. That every time we're multiplying by root 2? Yeah, it does, I think. Because if you multiply by root 2 twice in your life, that's the equivalent of you multiplying by 2, isn't it? Does that work for us? So that's the multiplier in this table, is root 2 as we go from left to right. And it won't be a nice number here. What is it approximately? 5.65? Do we round correctly? 5.65? Okay, I'll trust you. All right, and then you have some other numbers. Anyone have them all yet? Approximate values. So fill out the rest of the table. Multiply each number by root 2 to get the next number. I'm going to graph Miriam in blue. How about? Here we go. So these numbers are just these are slightly different, right? This is like 5.6 something there. It's a little below the green dot. 11.3. Just a little below the green dot again. 22 and change. Just a little below the green dot. 45. Oh, that's actually, what is that, 45? That's actually down here. Yeah? Does that make sense? So I think Miriam's graph looks a little more now. I mean, I don't know if I'm so cavalier as to connect these yet, but I think that's where we're going, right? Like that we can maybe eventually convince ourselves that it goes through all these blue and red dots. And maybe other values in between. The next piece is the table split up even more. What about the 1/3 and the 2/3? Can you, don't tell anybody. Well, what's the multiplier there as you go from left to right in the table? Think about it. Use the same kind of analysis we just did. What is it we're multiplying by each time here in this table? All right, think about that. All right, I think everyone maybe figured out the answers to 7 and 8 here. So number 7, we already said, what's the answer to 7? We already said that earlier. Number 7. In problem 5, what was the multiplier? In problem 5? Yeah, root 2. What's the multiplier for number 6, the one we just are now doing? Yeah, do you multiply by cube root of 2 each time? It makes sense to me because if you multiply by the cube root of 2 3 times in a row, that's the same as you multiplying just a number by 2, isn't it? That's a beautiful idea. Okay. Did anyone have another strategy for filling in the gaps in both the tables on 5 and 6? I know that there are a couple people out there who didn't think about it in this way and yet still got the right answer somehow. How'd you do it? Anyone else do it another way? My question is, guys, how does this relate back to the formula you came up with at the very beginning of class today? Does it still work, is the question. That is 4 times 2 to the t? Like if I asked for the value of, this value right here, when t is 2/3, does it also make sense to plug in 2/3 into our formula? And if so, why are these the same? What does that actually mean? 4 times 2 to the 2/3. Does that give you the same answer?
Yeah, that's like,
Is that the same thing as, what did we do here to get this answer? Didn't we multiply 4 by the cube root of 2 times the cube root of 2? Is that how we got this? So these are the 2 different ways. Why do they come out to be the same thing? I need you to do some soul searching on that, right? I think you can do it, right? This is also known as the cube root of 2 squared, isn't it? Is the cube root of 2 squared the same thing as 2 to the 2/3? I think I've been down this road before, haven't I? So I think I have a pretty good understanding of what to do when I raise 2 to different fractional powers. Do you? After last unit, even on the test, I asked you to take things 2 to the 2/3. You should know what that means, right? And yes, they do mean the same thing. Let's make sure we have a connection firmly in our mind between the formula we came up with and also this idea of a multiplier in the table. They should be one and the same concept. I want to leave you with one, I've got some homework for you too here in a second. I'll hand it out. I want to leave you with one other thought question in your life though. Are you ready? Okay. This is just rhetorical. You can think about it. Maybe you can let it keep you up at tonight. Okay. You should already be comfortable evaluating these expressions, like we've just talked about. Am I right? 2 to the 3rd, that means this. 2 to the 0, we've already talked about why that means 1. 2 to the negative 3rd, we realized it means that, right? 2 to the 1/3, we now understand after a week or 2 of talking about it. And 2 to the 5/3, we can even resolve as being that, yes? So are we good? Do we know how to raise 2 to any power?
yes.
What's missing? Well, I have one more question still in my mind. I think I know how to raise 2 to powers that are fractional. I know how to raise 2 to negative powers. But what about these? And how does that work?
Those are imaginary.
I think we should be able to, because on your graph, that you just constructed, if you connected that smooth curve, aren't these values on that curve? Isn't there a value for t equals 3.1415926 hours? You said that 2 to that power equals something. So if you claim that 2 to the pi is something we can do and get a reasonable result, then what does that even mean? How does your calculator do it? I have questions. Just something to think about and get back to me on, okay? Just for fun. Okay? Please don't go without getting this, which is your homework tonight, okay? Yeah. Reassessment at lunch today or after school?
Wait, this is the final place tomorrow.
Reassessment on last week's quiz. At lunch or after school if you need it. Have a nice day, guys. No. Alright. Very soon. Yeah.
Oh, you're right, today's Tuesday. It's Wednesday.
Yeah, we're gonna have all the recesses happening. You're taking reassessment right now? 3:15. If you're taking the reassessment right now, anyone doing that? Anybody taking the reassessment for last week's quiz? If so, let me know. Yeah, 3:15. She should be ready for you.
Yes. You want to do the interview?
No, anytime we offer one, you're welcome to take one. But it won't be always, right? As a habit, we will not always offer an assessment. We're not going to do that. But.
Okay, so the payment is, I'm probably Latino blank.
All right, we're
I'm going to the U.S. National.
doing them all in one room. 2 doors down.
And also pay it.
3:15. By rule, I mean give the actual inverse rule, the function.
Oh, the function.
Give me the rule.
So what was the and he's
3:15. 2 doors down. Yeah, if you're reassessing the quiz, it's in room 315. It's 2 doors down. 315.
I'm going all the way this time. Even though I'm trying to.
Okay. Very much.